Jai Hind students, welcome to my YouTube channel. Students, dreaming is not something that you see while sleeping. I repeat students, dreaming is not something that you see while sleeping. Dreaming actually is, or dreams actually are, something that does not let you sleep. So students, what I mean to say is that add wings to your imagination. Never ever hesitate to fly high. Dream big, but at the same time avoid daydreaming. What I mean is, dreams should be followed by appropriate actions. Whatever you dream, in order to realize it, hard work is the key. So, with dedication, with commitment, with devotion, with consistency in your effort, those dreams can eventually come true. Right, students? So, students, with that, let's begin this session. In this particular lecture, we are going to discuss a very important and interesting topic of thrust and pressure, right? So we'll first discuss about thrust and then I will introduce the term pressure. And before we begin, students, I would like you to watch the video till the very end, because I have included two short clippings in the form of animation in my video, so as to make the teaching learning process that much more interesting and enthralling, right? So let's start this session then, students. So let's discuss thrust. And again, before going to the definition directly, we must try to first understand the concept, isn't it? Let us consider this to be a body, students. This is a body and it is kept on a surface. This is a solid body. It is a solid body A and it is kept on a tabletop or any other surface B. Obviously, students, body A will exert a force equal to its weight on body B, right? And this is known as the weight. This force is known as the weight, which we are aware of. It is equal to M into G. So what I stated is, a body when placed on any surface, it exerts a force on the surface with which it is in contact, right? And this force is exerted by body A on body B normally. Normally means perpendicularly. Normally. It means that in the perpendicular direction, that is perpendicularly. Similarly, students, let's consider another case. It is the case of a solid body. Now let's consider the case of a fluid. Let us consider the case of a fluid. Liquids as well as gases, they can be termed as fluids. Substances which can flow, they are known as fluids. Let's consider a simple example. Suppose this is a vessel in which liquid is stored in it. Any liquid, and let us consider this is a small hole over here, right? It is an orifice, O-R-I-F-I-C-E, orifice or hole below the free surface of the liquid. Now obviously water will start, or the liquid will start coming from it, isn't it? Again I repeat, students, if there is a container containing some liquid and the container has got some holes, then the liquid will obviously tend to come out of that container, right? Now, if you want to block the hole with the help of our finger, so if you insert the finger over here so as to block the hole, so as to prevent the liquid from coming out of that hole, then what we will observe is a force which is being exerted by the fluid on our finger in the outward direction. So that force, students, that force which the liquid exerts in the perpendicular direction, that is known as thrust. Clear, students? So if you want to represent diagrammatically, then if this is a fluid, then the fluid exerts force on the surface with which it is in contact, always in the perpendicular direction. That is, it exerts a force normally on the surface with which it is in contact with. So it will exert a force at the bottom of the container like this, making an angle of 90 degree to the surface. These all are 90 degree. And on the surface of the container, it will again exert force. Again, it is 90 degree. So students, whether we are talking about solids or fluids, in both cases, the body exerts some force on the surface which it supports or with which it is in contact with normally, that is in the perpendicular direction. This force exerted by a body on a surface in the perpendicular direction is known as thrust. Clear, students? So thrust is a force acting on a surface normally, right? So it is a force. So I'll write down the definition. It is defined as the force on a surface acting normally. Acting normally. Normally means perpendicularly. Clear, students? So this is known as thrust. So thrust is nothing but it is a force exerted by a body on a surface, always in the perpendicular direction. And perpendicular direction, perpendicularly means normally. So the force exerted by a body on a surface normally or in a perpendicular direction, that is known as thrust. Clear, students? So since it is a force, therefore the SI unit of thrust must be same as that of force, that is Newton. We are aware the SI unit of force is Newton. Thrust being a force, its SI unit would be also Newton, represented by capital letter N, right? Now students, the impact of this force or the effect of this force is different on different surfaces. What I mean to say is that the effect of the force of equal magnitude is found to be different on different areas. Let us try to understand this statement. What I have stated is the effect of this force of same magnitude is found to be different on different areas. So let me elaborate with the help of various examples, right? So let me write the statement first. What I have stated is the effect of force, that is, okay, the effect of force, this is a very, very important statement. The effect of force of same magnitude. The effect of force of equal magnitude for different areas is different. Let me elaborate this particular statement. Again, I repeat, students. Just now we have discussed about the force exerted by a body, whether it is a solid, liquid or gas, right? We have just now discussed the force exerted by a body perpendicular to the surface with which it is in contact with. That is known as thrust. The effect of this force of equal magnitude is found to be different on different areas. Now, let us consider example 1. Now students, imagine yourself. You are standing on a loose ground. Loose ground means sand, right? So this is a loose ground and here you are standing. This is a body. And here you are standing like this. This is a body. So this is the area of contact. This is the area of contact. Here, this is the body, suppose. Now what happens is, suppose imagine this to be a person, right? And he is standing on a loose mud. Then what will happen, students? Our feet will sink into the loose mud, isn't it? And our feet will sink to quite an extent. It will sink deeper into the loose mud, right? Now consider the other case. This is case 1. Consider the other case. This is loose mud. And the person now, what happens is, earlier he was standing on the loose mud. Now he sleeps on the sand like this. Now he is in this particular position. Now what happens, students? In this case, obviously, the loose mud will sink, but to a much lesser extent as compared to case 1. Have I made my point, students? What I stated is, let us imagine a person to be standing on a loose mud. Then what happens is, the force in this case, which is equal to its weight, will act on smaller area. So the impact of force being larger, the person will tend to sink into the loose mud to a large extent. But when he is in this particular position, then due to the increase in the area of contact, the same force, which now also would be equal to the weight as was in case 1, but now the effect of this weight or the effect of this force is reduced to the lesser extent because of the increase in the area. So now the loose mud will sink, but to a very lesser extent as compared to the first case. Clear, students? Similarly, okay, in this case, in both the cases, the force is the weight. But here, suppose area A1 and this is area A2. This is the area of contact A2. Obviously here A2 is greater than A1. But impact in the first case, impact of force in case 1 is found to be greater than the impact of force in case 2. Understood, students? I am not talking about the force. In both the cases, force exerted by the body on the loose mud is same. But I am talking about the effect of force or the impact of force. Impact of force in this case is greater as compared to this case. Here the area of contact is smaller. Here the area of contact is larger. Right? You can consider other case. Okay, students, let's consider the second example. Right? We are aware of school bags. Right? There are some school bags having broad straps, while there are some other school bags having narrow straps. Right? So these are the two types of bags. Suppose one is having broad straps. These are having broad straps. B-R-O-A-D. Broad straps. And in the second case, suppose the same bag is having narrow strap. It is having narrow strap. Okay, let us consider in both the cases the same identical items are kept in the bag, in both the bags, right? So the weight of the bag would be same. The force exerted by the bag on the shoulders would be same in both the cases, which will be equal to the weight of the items inside the bag, right? Now in this case, students, this weight get distributed over larger area. So it is found that the impact of weight on one's shoulder would be quite less. While on the other hand, the impact of the weight on the bag in the case of narrow strap having smaller area would be severe. It would definitely give pain to the shoulder of the person carrying this bag with narrow strap. What I mean to say is, students, again, consider these two examples. Same weight, here also the same weight. So same force is acting, same force is being exerted by the body on the two cases, right? But they are acting on different areas. In one case, smaller area, and in the other case, larger area. In this case, the same weight is acting over smaller area and here over larger area. The impact of force on the larger area is found to be smaller as compared to the impact of force acting on the smaller area. Clear? So, what do you conclude from these two examples? Larger the area, larger, this is a very, very important conclusion, students. Larger the area of contact, larger the area of contact, smaller is the impact of force, right? While on the other hand, vice versa, that is, smaller the area of contact, smaller the area of contact, larger is the impact of force. Larger is the impact of force. So students, in such situations, it is not preferable to measure the total force. Actually, in such cases, it would be preferable to measure force acting per unit area. And from there, the concept of pressure is introduced. In all these cases, the force is not important, but the force acting on unit area, force acting per unit area, that gives the measure of the impact of the force. And in order to measure the impact of the force, this term pressure is introduced. So now I hope you have understood the concept, right? So pressure, definition, how you define pressure then? Pressure is the thrust acting per unit area. And thrust, you are aware, students, it is the force exerted by a body on a surface normally, that is in the perpendicular direction. So how to define pressure then? So pressure is thrust per unit area. It is thrust per unit area. Clear, students? Again I repeat. Pressure may be defined as the thrust per unit area, or it may be defined as the force exerted by a body on a surface normally per unit area. Force exerted by a body on a surface normally is known as thrust, and thrust per unit area is known as pressure, right? So pressure is thrust acting per unit area. Clear, students? So this is the concept of pressure. Now, before we proceed further, I would like you to watch this short clipping, which would certainly make the concepts that much more clearer, right? I'll explain with the help of some other examples as well. So do watch this short animation, right? The pressure depends upon the magnitude of the force and the area. For a given force, the pressure of a body can be reduced by increasing the area. This principle is widely used in our daily life. For example, the foundation of a building is made wider to reduce the pressure of the building. Similarly, the walls of the dams are made wider at the base so that it can withstand the pressure of water. Buses and trucks have broad and double wheels so that the pressure on the tire is reduced and they do not burst, as well as they exert less pressure on the ground. Similarly, the rails on the railway track are fixed to large, wide wooden sleepers. The heavy thrust of the train on the rail is spread over the large surface area of the sleepers, and thus the pressure is greatly reduced on the ground. And as a result, it prevents the rails from sinking into the earth under heavy pressure. All cutting and piercing tools like knives, scissors, needles, saw axes have sharp edges so that they exert great pressure with minimum force. Okay students, I hope you have understood the various examples which were given in this short clipping, right? Now again, let me repeat it. What we have discussed is thrust. Thrust is the force exerted by a body on a surface normally. Normally means in a perpendicular direction. And this force exerted by a body normally per unit area is known as pressure. So, pressure we have discussed is equal to thrust, which is the force acting normally on a surface per unit area. This is the mathematical expression for pressure, right? Now regarding its SI unit, students, there are various units, but first discuss the SI unit. SI stands for Standard International, right? It is actually a French term. The abbreviation SI stands for System International. System International D units, right? So SI unit of pressure is, okay, thrust, as we are aware, it is force, so its SI unit is Newton. Area, its SI unit is meter square. So therefore SI unit is Newton per meter square. And students, Newton per meter square is also known as Pascal. Pascal is the unit which is we use, and it is after the name of great scientist Blaise Pascal. So remember, SI unit of pressure is also known as Pascal. So 1 Pascal, it will be represented like this, P in capital letter, A in small letter. It is equal to 1 Newton per meter square. Clear, students? So when the pressure is said to be 1 Pascal, when a force of 1 Newton acts on a surface normally, and that surface should have an area of 1 meter square, then the pressure exerted may be said to be 1 Pascal. So suppose this is a surface, and here a force of 1 Newton acts in the perpendicular direction, right? And the area of the surface is 1 meter square. Then the impact of this force, that is the pressure, it would be equal to 1 Pascal or 1 Newton per meter square. So when a force of 1 Newton acts on a surface normally having unit area, then the pressure exerted on the surface is said to be 1 Pascal. Clear, students? There are some other units of pressure as well, like bar. Other units. Let's discuss other units. Bar. It is another unit. 1 bar. It is equal to 10 raised to power 5 Pascal, or 10 raised to power 5 Newton per meter square. 1 Pascal is 1 Newton per meter square. So bar is another unit for measuring pressure, right? Then there is atmospheric pressure. Atmospheric pressure. And it is represented as ATM. It is not auto teller machine, right? ATM. Here it stands for atmospheric pressure. And atmospheric pressure at sea level is measured to be 1.013 into 10 raised to power 5 Pascal. So students, it can be written as 1.013. 10 raised to power 5 Pascal is bar. So it can be written as 1.013 bar. So this is the atmospheric pressure at sea level, right? So these are the various units for measuring pressure. Now let me give you a simple elaboration of the concept that the impact of force of same magnitude but on different areas is different. Let me explain again this very important statement mathematically. So what I do is, students, suppose this is a block. This is a block maybe of dimensions. Suppose its dimensions is 5 centimeter. This is suppose 10 centimeter, and let us consider it to be 20 centimeter. This length, breadth and height. This is a cubical block, right? And its mass is suppose 10 kg, right? Now, in the first case, in the first scenario, it's placed like this, with this area in contact. Now, what is the pressure exerted by this body on the surface in contact, right? So, what will be the force? Force would be equal to weight, and it is equal to mg. We are aware of it. Mass is 10. The value of g, which is acceleration due to gravity, can be considered to be 10 instead of 9.8. Just to simplify the calculations, let's consider it to be 10. So it will be equal to 100 Newton, right? This is the force. And what about the area? Which area is to be considered? The area of the body which is in contact, right? And here the weight will be acting like this. This is the weight. And this is the area of contact, which is placed on the supporting surface, right? So what will be the area? 10 centimeter into 5 centimeter. This is the area. So it will be 50 centimeters square. So it will be 50. Don't forget to convert it in meters. 1 centimeter square is, or 1 centimeter is 10 to minus 2 meter. So we can write it like this. So it will be 50 into 10 to the power minus 4 meters square. Clear, students? So what about the pressure in this case? Pressure is force per unit area. So it will be equal to 100 divided by 50 into 10 to the minus 4. So what we get is 2 into 10 raised to the power 4 Pascal. So this is case 1. Let us consider this to be case 1, right? Now what to do is, we'll consider the same body, but now it is placed on the supporting surface in a different manner. Suppose its orientation is changed. Let us consider its orientation to be changed. So now let us calculate the impact of the force, which is the weight in this case as well. So in the second case, what we consider is, let us consider the same cubical block to be placed in this particular manner. Now in this case, this area is in contact with the supporting surface, right? Its dimension is 10, actually it is 20, and this is 5. This is 5 centimeter. Weight of the same block, it will remain constant, isn't it? Weight will remain constant. So, here pressure would be, suppose it is P dash, it will be again formalized F by A. F by A. Force, which is equivalent to weight, it will remain same in both the cases, right? So, what is F, which is weight, which is 100 Newton? What is area? 20 into 5 centimeter. So, area is 20 into 5 centimeter square. So, it will be 100 centimeters square. Isn't it, students? So, 100 centimeters square. So, 100 into 1 centimeter square is 10 raised to the power minus 4 meters square. 10 raised to the power minus 4 meters square. So, what we get is 100 get cancelled. So, we will get 10 raised to the power 4 Newton per meter square. This is P dash. Now, students, observe these two. What do you get? P is greater than P dash. So, from A and B, we observe that P is greater than P dash. Clear, students? So, what we conclude, what we have mathematically verified is that in both the cases, the force which is equivalent to the weight of the body in both the cases is same. But due to the different orientation, the area of contact would be different. The greater the area of contact, the smaller will be the impact of force. The smaller will be the pressure. The smaller the area of contact, the more will be the impact of force. The more will be the pressure exerted by the body on the surface. So, pressure is inversely proportional to the area. So, for force to be constant, pressure is inversely proportional to the area. If area is more, then pressure will decrease. And if area decreases, then the impact of force, that is the pressure, will increase. It's a simple concept. Again, students, I would like you to watch another very short and interesting animation based on the advantages of low pressure and the advantages of high pressure, right? This will be again quite interesting for you, right? We can use drill machine to drill hole into the wall. It has a pointed tip to increase the pressure. You can easily cut vegetables with the cutting edge of the knife. But if you use blunt edge, it will be difficult to penetrate it in. What is the reason? Well, the cutting edge has small triangle-like shapes which are sharp outer points, but the blunt edge has nothing of these. So if you cut vegetables with the cutting edge, the area of contact between the vegetable and knife is greatly reduced and hence more pressure is exerted. This tool used to cut the trees or wood also have sharp cutting edges instead of placid ones. It increases the pressure and impact of force. The examples that we have discussed so far are applications of high pressure. But there are some situations or applications where we require low pressure. Let us now see some advantages of low pressure. We use snowshoes to walk on snow. Due to large area of contact of snowshoes with the snow, it reduces the pressure and we are able to walk on it without our feet sinking inside. While in the case of normal shoes, due to this small area in contact, more pressure is exerted and it sinks, making it difficult to walk. It must be remembered in both the cases, the force applied is equivalent to our weight. Have you ever wondered why the wheels of this army tank run on the steel track rather than on the ground? It is because steel tracks have large area of contact with the ground. As a result of this large area of contact, the weight of the tank which is used get distributed over larger area and thus lesser pressure is exerted on the ground. Okay students, before we end this session, there's another very interesting fact which I would like to discuss in this particular session, right? This is regarding atmospheric pressure and the force exerted on our body due to that atmospheric pressure, right? Now atmospheric pressure, it is the pressure exerted by the Earth's atmosphere. Now Earth's atmosphere, it must be having some weight, isn't it? So whatever force it is exerting per unit area in a direction perpendicular, that is known as atmospheric pressure. And students, we are aware 1 atm, that is atmospheric pressure, it is equal to 1.013 into 10 raised to the power 5 Pascal. Please do remember it. It's an additional knowledge, but you should be aware of it, right? This is atmospheric pressure. This is atmospheric pressure. Now, a normal adult, the surface area of a normal body of a human being is about 1.5 meters square. It is the area, or rather it is the surface area of a human body. It is about 1.5 meters square. So due to the atmospheric pressure, what is the force which is being exerted on the human body by the gas surrounding us? So we know that pressure is force per unit area. This is the formula, isn't it? So force would be equal to pressure multiplied by area. So the force acting on our body due to the atmospheric pressure would be, what is the atmospheric pressure? It is 1.013 into 10 raised to the 5. It is in Pascal, that is Newton per meter square, multiplied by, what is the surface area of a normal average adult human body? That is about 1.5 meters square. 1.5 meters square. So it would be 1.013 multiplied by 1.5 into 10 raised to the 5. Per meter square get cancelled, so we will obtain the force in Newton. So it is equal to, you can calculate it, 1.5 multiplied by 1.0, it is something a little bit greater than 1. So it will be actually something about 1.52 into 10 raised to the 5 Newton. Students, this is a huge force, 10 raised to the 5. It's a huge force which is acting on our body due to the Earth's atmosphere surrounding us. It's a huge impact. But how we are able to sustain it? That's the question. How we are able to sustain this huge force which are being exerted on us by the Earth's atmosphere? The reason is, students, our body, it contains several pores. There are numerous pores, holes, through which the air from outside can get inside. There is a communication between the outer and the inner environment. So a balance is maintained. The internal pressure which the fluid inside our body exert in the outward direction is exactly balanced by the atmospheric pressure which acts in the inward direction. So there is a delicate balance between these two, between the internal pressure and the external pressure. And that is because of the pores in our body through which the air can communicate from inside and outside. So there is a balance between the internal pressure due to the blood running through the veins. They also exert pressure in the outward direction. So that balances the external atmospheric pressure. So that is how the shape of the body is maintained. Or else we would have squeezed down, isn't it? So anyways, whenever this delicate balance is disturbed, like when we go higher altitude, when we move to some place which is located at very high altitude, then the atmospheric pressure decreases, internal pressure increases, so the balance is not there, isn't it? Imbalance, a sort of imbalance is created. So that is where the problem arises. Sometimes the bleeding starts from the nose, isn't it? That's due to the imbalance between the internal and the external pressure. The same happens when we go deep inside a sea. Again, there the external pressure increases and the internal pressure is not that of the same order. So again, due to the imbalance, some problems are faced. So we need to take accordingly measures. We need to take some precautionary measure so as to maintain that balance, right? So this was a question just for a general awareness. So students, in this lecture, what we have discussed is basically thrust, any force exerted by a body on a surface normally, that is in a perpendicular direction, that is known as thrust. It is a force, SI unit is Newton. And the impact of this thrust on different areas is different. Smaller the area, the impact of thrust is more. Larger the area, the impact of thrust is lesser. So there comes the introduction of this topic of pressure. Pressure is thrust per unit area. So more the area for a given thrust, lesser will be the pressure. Lesser the area of contact for the same thrust, more will be the impact, more will be the pressure. And then we have discussed the SI unit of pressure, which is Pascal, named after famous scientist Blaise Pascal. And it is also Newton per meter square. Right, students? And thereafter we have discussed various examples. So I hope you have understood this topic and you must have enjoyed this session. So do join me in my next lecture. Always stay blessed and always be happy. Thank you.